In this video, we're going to talk about logarithms and logarithmic functions. So let's talk about why we need logarithms. Let's say you have an exponential function y equals 2 to the x. And how do you find the inverse of exponential function y equals 2 to the x? Well, if you remember, if you want to find the inverse, you have to interchange x and y value. X equals 2 to the y. And we need to solve for y. And there is no way we could solve for y here. That's why we need logarithms. Also, let's say you have an exponential function, 2 to the x equals 5. And you want to solve for x. If it was 2 to the x equals 4, x is easy to solve because 2 to the x equals 2 squared. So we know that x equals 2. But in this case, it's not so simple. That's why we need logarithms. Let's talk about definition of logarithms. Let's say b and y are positive real numbers where b is not equal to 1. So when you have an exponential function, b to the x equals y, this will be equal to, if this is true, if and only if log base b y equals x. Again, the logarithm is inverse of exponential, or you could say that exponential is inverse of logarithmic functions. And we'll look at some more examples. So let's say you want to change logarithmic to exponential. Let's say you got log base b of 216 equals 3. If you want to change that to an exponential, what is a base? Base is 6. And x here is 3. And that will equal to 216. So we just change the logarithmic to exponential. What if you have log base 7 of 1 equals 0? You could say that it will be 7, x is 0, 7 to the 0 is 1. Another way of you interpret logarithm is that logs are exponents. Logs are exponents. Logs are exponents. So whenever log of something is equal to a number, that number will be an exponent. So you got log base 21 of 21 equals 1. Remember, logs are exponent. So base is 21. What is exponent? It's 1. Equals 21. What about this one? What is a base? Base is 1 over 5. Again, logs are exponents. So exponent is negative 1. So base 1/5 to the negative 1 is equal to 5. We just change the logs to exponents. Here we have 4 exponential equations. So we're going to change it to logarithmic. What is a base? Base is 9. So log base 9 of 81. Because what are logs again? Logs are exponent. What is exponent here? 2. So as long as you know the base and exponent, it's easy to go back and forth. And for this one, what is a base? Base is 20. What about the exponent? Exponent is negative 1. So log base 20 of 0.05 is negative 1 because logs are, again, what? Exponents. What about this one? Base is 16. Exponent is 3 over 4. So log base 16 of 8 is 3 over 4. What about this one? The base is 15. Exponent is negative 2. So log 15 of 1 over 225 is negative 2. Before we go over the next examples, these two are valuable information that you need to know. What is log base b of 1? So let's just call this x. In other words, b to the power of x equals 1. And what is the value of x that will make the base when the base to the x equals 1? Well, that's when x equals 0. Because we know that b is a positive real and b is not 1. So anything you raise b to the power of 0 will be 1. So whenever you have log base b of 1, that whole thing will be 0. So for example, let's say you got log of base 9 of 1. And you know that this whole thing will be automatically 0. What about log base b of b? These two are the same. Again, let's set that equal to x. If you change it to exponential, you get b to the x equals b. Well, that's 1 right there. So x equals 1. So whenever these two are the same, let's say log base 10 of 10, you know that will be equal to 1. What about log of base 12 and 12? That's also 1. So these two are valuable information. We need to evaluate these 4 expressions. So we got log of base 4 of 256. Well, let's set the whole thing equal to x. So this means 4 to the x equals 256. And what is 256? Well, that is 4 to the 4th power. So what is x? X equals 4, which means that this whole thing right here, log base 4 of 256 is equal to 4. What about this example? Log base 8 of 0.125. Again, let's make that whole thing equal to x. Change it to exponential. 8 to the x equals 0.125. Now you know that, yeah, actually it's not obvious, but 8 to the x is same thing as 8 to the 0.125 is same thing as 8 to the negative 1. So x is equal to negative 1. Therefore, this whole thing right here is negative 1. So what about this one? Log base 1/3 of 27. Let's set that equal to x. So 1/3 to the power of x is equal to 27. Now, 1/3, in order to compare the exponent, you need to have the same base. I'm going to change it to 3 to the negative 1 to the x equals 3 to the 3rd power. Because 1/3 is the same thing as 3 to the negative 1. So now you want to multiply the exponents. So x is equal to negative 3. So that means this whole thing right here is negative 3. What about this one? Log base 64 of 8. Well, I'm going to make it into x again. So change it to exponential. 64 to the x equals 8. What is 64? That's 8 squared, isn't it? So you get 8 to the x equals 8. Exponent is 1. Therefore, x has to be 1/2. So that means this whole thing right here is 1/2. Before we go on to the next example, we want to talk about common logarithm and natural logarithm. Common logarithm is when the base of a log is 10. If the base is 10, we don't usually write the 10. So if you don't see a base, that means there's an invisible 10. So for example, let's say you have a log of 9. This is the same thing as log base 10 of 9. So if you don't see a base, that means they're invisible 10. Now the natural logarithm is when the base is e. Remember e? We talked about it earlier in another video. When the base is e, we write log of base e of x as ln of x. So for example, log of base e of 7, we write it as natural log of 7. Log base e of 15 will be natural log of 15. So these are common logarithms and natural logarithms. Let's simplify 10 to the log of base 10 of 18 or log of 18. So let's just represent this whole thing as y. Now, is this an exponential or logarithmic form? This is actually exponential form. What is a base? Base is 10. What's the exponent? What is the exponent? Log of 18. So you could write it as log base 10 of y equals log of 18. But what is the invisible base right here? It's 10. It's a common logarithm. Now, in order for this to equal to each other, what is the value of y? Y has to be 18. That means this whole thing right here is equal to 18. Let's simplify. Log base 4 of 16 to the x. In order to simplify this, let's call this whole thing equal to y. Now, this is a logarithmic form, so let's change it to exponential. What is a base? 4. Logs are exponent, so 4 to the y equals 16 to the x. Remember, our goal is to find the value of y because this whole thing represents y. So let's change it to same base. So you get 4 to the y is 4 2x. 4 to the 2x. So what is y? In order for them to equal to each other, y has to equal to 2x. That means this whole thing right here has to equal to y, which is 2x. How do you find the inverse of f of x equals 6 to the x? In other words, let's say y equals 6 to the x. How do you find the inverse of this? Well, remember, in order to find inverse, you have to say x, you have to change x and y. And then now you have to solve for y. How do you do that? Well, now we have logarithm. So what are logs again? Logs are exponents. So what is the base? Log base 6 of x equals y. So what is the inverse of f of x equals 6 to the x? The inverse will be log base 6 of x. So in other words, if you have f of x equals, let's say, 7 to the x, the inverse function, inverse of that will be log base 7 of x. How do you find the inverse of y equals natural log of x plus 3? Well, first we need to interchange x and y. And we're going to solve for y. Remember, natural log is the log with base e. So how do you write that into exponential? It's going to be base e to the x, the logs are exponents, equals y plus 3. And solve for y. What is y? Y equals e to the x minus 3. So the inverse of this function will be this, e to the x minus 3.